Hello everyone, this is DSA Zindabad. Today we are going to solve the 26th question of our square DSA sheet, and the question is insert, delete, get random, duplicates allowed. So now let's look at the problem statement. A randomized collection is a data structure that contains a collection of numbers, possibly duplicates, that is a multiset. It should support inserting and removing specific elements and also reporting a random element. So what you need to do, you need to implement the randomized collection class. Randomized collection initiates the empty randomized collection object. It's a kind of constructor, like it will be constructor, right, which will initialize the empty randomized collection object. So second one is bool insert int val, which basically inserts an item val into the multiset even if the item is already present, returns true if the item is not present, false otherwise, right? And bools remove interval removes an item val from the multiset if present, returns true if the item is present, false otherwise. Note that if value has multiple occurrences in the multiset, we only need to remove one of them, right? It totally depends on us, like what we want to remove, like, right? So there is the fourth one, which is integrate random, and it returns a random element from the current multiset of elements. The probability of each element being returned is linearly related to the number of the same values of the multiset. You must implement the function of the class such that each function works on an average of big of one time complexity. The note the test cases are generated such that get random will only be called if there is at least one item in the randomized collection, right? So what we need to do, we need to implement a randomized collection class, right? So basically it will have constructor and these three functions. First one is insert, second one is remove, and the third one is get function, right? So we just need to implement these three functions. So for the insert, what we need to do, like we just need to implement an insert function which inserts an item well into the multiset, right? Even if the item is already present, let's say we are inserting some elements in the uh, like set which contains like 1, 2, 3, 4. Let's say if we are inserting one, then it will be inserted into this like kind of data structure, right? This is what is meant by this line. Like if the even if the item is already present, right? So one will be inserted into this array, right? So what we need to do, like this function will return true if the item is not present, right? False otherwise, right? Remember, it will return true if the item is not present. True if not present. False if present. P is for present over there, right? So now let's look at the remove function also. It basically removes an item val from the multiset if present. It need to return true if the item is not present. True if the item is not present. False otherwise. False otherwise, right? And let's say if val has multiple occurrences, let's say if we have 1, 2, 3, 4, 5, 1 in our multiset, right? So let's say if you want to remove one. So what does this mean? Like if val has multiple occurrences in the multiset, then we only remove one of them. Let's say if we decided to remove this one, right? It totally depends on our choice what we want to remove, right? And the fourth function, the third function is which is getRandom, which basically returns a random element from the current multiset of elements. The probability of each element being returned is linearly related to the number of the same values the multiset contains. So we just need to implement a random function which will return any random number, right? So we just need to think about this a little bit, right? So now let's look at the example and try to understand what the problem statement is like so that you guys have a better understanding, right? So here we are. Let's say our input is something like this: randomized collection, insert, 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 get random. These all are the function. This one is the constructor over there, right? Constructor, right? This one is these all are the functions, right? Initially, this will be something like this empty. This will create a empty list, right? One like one basically here means we are inserting one. Let's say this is a initially we have empty. So after inserting one, this will become something like this. So again, after inserting like over there, insert one, it will return true since the collection does not contain one, right? So initially it will return true, right? Again, like there is the call of this function, which is insert again. So again, we are inserting one over there. So now it will contain duplicate element, right? So it will return false since the collection contains one, right? It will return false. because since the collection contains already one, right? So now we have GetRandom. Now the list something look something like this, which is one randomized collection insert two. Now we are inserting two into our list into a multiset one two. Since two is not there, so it will return true, right? Insert two into the collection now contains one two, right? So now we are calling get random, so it basically return one with probability of being 2 by 3. Why 2 by 3? Because all the elements contain three, so the probability of choosing one over there is 2 by 3, right? And the probability of choosing two with the is probability is 1 by 3, right? So it will return either one of them, right? So now what we have a remove function again. So let's say at this point of time we are returning one, right? So now randomized collection dot remove. What we need to remove? We need to remove one. So let's say if we want to remove this one, a remove function is applied over there. So our list becomes something like this: 1, 2. So it will return true since the collection contains one, right? It will return true because one is already there in our multiset, right? That's why it return true over there. So now our list something look like something like this, which is 1, 2. So now the last function is get random. So randomized collection get random. Get random should return one or two, both equally likely, right? There is like equal chance of both the numbers to be selected, right? I hope this problem statement is clear to all of you guys. And remember what we need to do. We just need to like time complexity should be big of one on average case. Right. Now let's jump into the approach and try to think how we can solve this question, right? So here we are. Now let's think about the approach, right? So there is this one line which contains time complexity should be big of one on average case. What data structure comes to your mind when you think about this line? Obviously hash map. So all of you get this intuition like will be like kind of using hash map because like the question says the time complexity should be big of one on average case, right? So it is quite obvious like we're gonna use hash map, right? So like what we need to do, like we need to perform three function insert, remove, and the third one is get rid. So let's first talk about this two function, right? Let's say we have like we kind of need something to store all the numbers. Let's say we have this, so we kind of need something like list to store the numbers, right? To store numbers over there, right? Like just think about the insert function, how we can insert, where we can insert some numbers, obviously a list or vector or array, right? So we kind of need like list, vector or array to store numbers, right? Obviously this is quite obvious, right? To store the numbers, right? So now the second thing, let's say we insert all the elements. Now think about, you guys be like insert function is quite obvious, like we just need to insert all the elements into like some kind of list. So this will on an average like take big of one time. Yeah, this is absolutely fine. Now think about the remove function. Let's say uh, from this array, like from this list 1, 1, 2, 3, 4. Let's say I say you just need to remove 4, or you just need to remove 1 from the given list. So you guys will like let's try to remove this one. These are the indices, right? So now let's try to remove 1 from the given list. So how we can remove 1 from the given list? So you guys might be like, let's say if we are removing 1, then we just need to shift all the elements over there and also the indices, right? Yeah, but is it a time? Is it taking time complexity big of fun on an average? No, this is not taking. This is taking much larger time complexity than big of fun, right? Obviously, because we just need to iterate over the array to shift all the indices. And let's say if we want to remove something 3 over there, then we again need to recompute all the elements, right? To rearrange all the elements in the given list, right? So we kind of need something, let's say we kind of need some hash map. Like why we are using hash map? What's the meaning of hash map? Like it's a kind of like key value pair, right? Insert function is like quite obvious. Like we just take a list where we directly store all the elements and it will require big of content, right? So the tricky part is the remove function. So let's say we find the index of the element using the hash map. We use the this trick to remove the element from the list in big of one. Since the it's kind of like we kind of use hash map key value pair, right? Let's say if we want to remove the element at the ith index, we can simply swap the ith element and the last element, right? And perform an big of one pop. Technically, we don't have to swap. We just have to copy the last element into the index I because it's popped anyway, right? This is quite obvious, right? With this thing in our mind, like the most difficult part of the problem becomes finding the index of the element we have to remove, right? We just need to find the index of a particular element which we want to remove. So all we all we have to do is have a kind of like data structure that maps the element values to their indices, right? So what do I mean? Like let's say we kind of need hash map in which the key will be element and the value will be index, so that we can directly remove all the elements from the hash map in big O content. And since here in the question there can be duplicates, so we just need to take care of this thing also, duplicates. So for duplicates, the index will be there will not be a single index, it will be indices. So for as we know, like indices will be unique. Over there, we have one, right? These all this one number is the duplicate number, right? So it have two index, and these indices are unique. So we kind of need something unordered set as the like to store all the indices. So the key will be element and the value will be unordered set, so that we can map all the indices to a particular element and we can directly remove the element from the set, from a like multi-set you can say, in which is given in the question, right? So with the help of this, we can achieve a remove function in big of one on an average, right? So now let's talk about the third function, which is getRandom. Now talk about the third function, which is getRandom. So for getRandom, what we'll be using, we'll use kind of uniform distribution. Uniform distribution, right? And in this, what we'll do, we'll just provide the range, let's say 0 to list dot size minus 1. And you guys will be like, why we are using uniform distribution, right? Let's think about if we are not using uniform distribution. Without a uniform distribution, if we were to generate a random numbers like without any constraint, right? Each number would have an equal chance of being selected, right? But the distribution of indices in the vector might not be uniform, right? All of you will agree on this. Like this might not be uniform. For example, if we get random numbers between 0 to this list size minus 1 without any constraint, right? Without any constraint, remember, some indices might be selected more frequently than others. This might be the possibility, right? However, like using this distribution ensures that each index has e equal probability of being selected. Equal probability of being selected. This is important for the randomness requirement of selecting elements from a collection like list. In this scenario, like it really guarantees that each element in the collection has an equal chance being chosen when calling like this function, right? That's why we are using uniform distribution over there, so that each and every element has an equal chance of equal probability of being selected, right? I hope this approach is clear to all of you guys, like how we are using hash map, why we are using hash map, so that like we can achieve each and everything in big of one on an average case, right? And why we are using uniform distribution to ensure that each and every element has an equal chance of being selected, right? Now let's try to code this thing up so that this thing will be clear to all of you guys. So here we are. Initially, what we'll do, we'll declare some private members over there. First of all, we'll have a list to store all the elements, right? And second, we'll have a noded map. A noded map. In this, what we'll have int. This one is for the key value. Like key is their like element, and over there we'll have a noded set for storing all the indices, since indices are unique. So there is no question over there. So this will be IDX, right? And the third one is for a random distribution, like to generate a random function or random number. This will be RNT. Default random engine is like to generate a random number from the given list, right? Over there, we'll have something uh, random, and over there we'll have a random device. Yeah. So this will create an empty, like this will initially create all of this thing when this is called as an object. Now, let's talk about the bool insert function, right? So, first of all, let's say we are just pushing all the elements in our list, right? Right. This function inserts a value into the collection. So before like inserting into the collection, we just need to check one condition: if the value is present in the hash map or not. Like, what do I mean? If the value is present in the hash map, just need to check. Well, if not, it will initialize an empty set for that value, right? IDX of val will be equal to this unordered set. Let me just paste this thing. Unordered set for that value, right? After this, what we'll do? We'll directly insert all the indices. So since we push back, and now we just need to return the bool function. IDX. Well, if this is equal to 1, then we just need to return 3, right? Because over there, like returns true if the item is not present, right? This is for the insert function. Otherwise, like will directly return false. Now let's talk about the remove function. So this function removes a value from the collection, right? It basically first check if the value exists in the index map, and if not, if its set is not non-empty, right? So check if the value it is non-empty, dxval dot size equal 0. If this condition holds true, then we just need to return false, right? Let's say now we'll just, if it does, like it removes the index of the value from the set. Now what we need to do, we just need to remove the index of the value from the set. And what we also need to do, we also need to do like swapping, swap the last element of the vector with the removed element. And we just need to update the index accordingly and then remove the last element from the vector, right? So let me just do this thing. Now we'll have remove index, which will be equal to idx value dot begin. This is like getting the first index of a particular of that value. Like over there, this is mentioned like note that if val has multiple occurrences in the multiset, we only need to remove one of them. So we'll get the first index. Now idx val dot erase remove index, right? Now we remove the index of that element from the set. So now we just need to swap this with the last element. So we'll directly get the last. Now lst of remove index will be equal to last, and idx of last will be equal to no idx of last dot. Now we just need to insert. We need to insert. We just need to insert the index, and we also need to update the length. It is lst dot size -1, right? Now at the end of this, we just need to pop. We are popping this thing from the back because we are just removing the last index. Now we just need to return true, right? Now let's write this function also, which is GetRandom, right? So we'll be following uniform distribution as we talked about this thing earlier. Uniform, how we are writing this thing. This is how we write this thing in C++. Distribution int. This one is the object for like using the uniform int distribution, right? It will directly pass the size. This is specified range. So this will be -1, right? Now we just need to return any number, right? So that each and every element has an equal chance of getting selected. Okay. So this end is used over there. That's why we declare here like a random engine. Over there, we also declare a random device over there. This is how we declare this thing in C++, right? I'll also tell the link in the description so that you guys have a better understanding of like a random engine and a random device, right? So now let's try to run this code. So let's submit this code. Yeah, this is accepted. I hope this approach is clear to all of you guys. And since we are using hash map and like list over there, so it will require big of 1 on an average case, but in the worst case, it will definitely require big of n, right? I hope this approach is clear to all of you guys. Thank you so much for viewing the video till the end. Please do like, share, subscribe, and comment if you have any doubt. Thank you so much.